recording it, yeah. Chapter.
If you click the setting, there's a session setting, and just tick the box, post chat messages.
Settings. Bit here. Setting.
Yeah, session settings.
Session, that's the one, yeah.
Yeah, tick the box,
So,
post a message, then all done.
Tick the, yeah, that's it. Yeah,
yeah.
And share, you want to do a video as well?
The students doesn't need to share anything, so unless someone wants to, yeah, this is fine. Unless someone wants to say something, you can make them as a presenter. That's all. But I don't think this is the case. Yeah.
Okay, right. So settings done. So
yeah, I think you have already started the recording, right?
Yeah, I've started.
Yeah. Okay, great.
Yeah.
Looks all good. So I leave you here. Okay, bye.
Thanks, mate. I'll leave it just a couple more minutes for to set up for everyone to come, and then we'll start.
Okay. Bye for now. Yeah.
Thanks. Bye. Now. Content. Screen. Sure. Okay. So, okay, I'm going to start very shortly now. Just what we're going to do today is just to summarise what's been covered in this week. Just have to go through what's been covered. That's what I want to do today. Just going to have a minute to do free to chat to ask any questions you have. As you see, I've already answered some of the questions that were given in the office hour on the module announcements, so I will also do that as well to put in writing to give a formal answers. So I hope you're all able to get there. Attendees, yeah, okay, good. Okay, let's start. Okay, so what I'm doing is I'm going through the week 3. What have we covered in week 3? Well, as you can see, it starts off with project management, and then we go on to design principles. Okay, so what we're doing. So we're moving on from software engineering. So software engineering is about producing programs, but it's large scale programs, and that's the first thing to understand. When you learn to program, of course, you write small pieces of program, but real program produced for real industry is going to be very much larger, and it's hugely larger. And that's the big thing to see the difference between all the things that have to be done when we're dealing with very large scale programs, realistic programs that are really used. So we start off by looking at the management. So a whole team of programmers is producing programs. And well, first of all, we looked at previously at how the requirements for the programs, what they're meant to do, what they needed to do. But then how do we design them to do it? And they have a whole team of programmers doing that. So that's the issue. Okay, so that's one to start looking at that. I'm just going to go very quickly through what they do. Okay, the planning, scheduling, managing people, and also the agile project management. So that's an important issue. So traditional software engineering had the idea, it's called the waterfall approach, that you would start off by doing all the requirements for the program, and detail what it should do, and then design it, and only then code it, the whole program, and then test it. And then that was the traditional approach. That was thought to be very good because to very carefully organize it and design it first before you start producing it. The Agile took it rather differently. And the reason why the Agile did this is because if you produce code, design it, it's very hard to know how long it's going to take to do it and what's required. So the Agile approach says produce perhaps more quickly a small early version of a program, and then add extra features to it later on, and interact with the customer of it to see what they want, what more features they do. And that's because it's a better way of producing programs to do it that way. The Agile approach to have links with the customer throughout because the customer's hard to know and decide exactly what they want. So seeing an early version of it is good, and then just looking at how it works and thinking it can help better. But one of the aspects of Agile is that if you keep adding new features to it, even more it's important that the structure of a code is done well, so that it is easy to see what you need to do to add these new features to it. Okay, so that's project management. Just go quickly through it. Okay, so you see, just quickly go through what it covers all these things. Says it's software. Well, management of architecture is software. It's a different. Perhaps Agile considers it's perhaps a different way of doing software, producing software, which is architecture. Architecture, of course, you would have to design it all in advance and then produce it. Whereas software is much more adding features, new features one at a time. Okay. So anything else we need to cover? So you can either look at these in more detail, and the lectures have already been done. So effective management. Okay. Management, how do we divide up the work requirements for producing the program? Okay. And this is what we're going through here. I'm just going through it quickly. Okay. Scheduling, dividing it into parts, scheduling it. And then we look at this in more detail in Project Management Part 2 for risk analysis problems. So we can't be sure that everything is going to go right when we produce programs. Things can go wrong. And we look at that in more detail in the risk management. Charts on it. Okay, so this is a chart and various parts of the program that need to be produced and the estimate of the time it will take to do it. So in some parts, of course, can only be produced after our parts have been produced, so that will affect the time, and that's what we're doing here. So parts need to produce, and we've got here, we produce something which is the, as it said, where are we? We produce particular requirements. Okay, and we allocate various tasks to various workers who are part of the members of the team that are producing the code. Okay. So managing groups, management, group working. Okay, so that's also software engineering is about producing code, but also about the human side of it, of course, of the managing. How do we manage people doing it? It's also an important aspect of software engineering, just for general management and agile project management. Slightly different approach, it says here. Okay. Okay, so here so Scrum is a version of Agile. Break it into chunks, as it says. It's a whole bit of everything, and can all the code of that. Okay, and trust between customers increments, as I said. So, okay, so that was the first lecture on project management part 1. Project management part 2. Okay, okay, so this is the second one, and also remember that the rest of it are the lectures that I pre-recorded lectures that I produced. Project management part 2, there's actually 4 separate lectures. They're short ones. So how I did it. In fact, the lectures that have been put online, the online lectures for it, were not originally designed for teaching in Beijing because of a situation where we're locked in, we're not allowed to travel, we can't give the lectures ourselves. They've been used for that. They are quite short, those lectures, because of the way they were produced. So I do want to add some extra features, aspects to just take them a little bit further, particularly if you feel you need to. So do ask questions about it. So it was divided in Project Management Part 2 into 4 short lectures covering small parts of the slides. So again, what I'm going to do is just go quickly through the slides to just try to summarize what this is all about. Okay. Project Management Part 2. Slides come up. Okay, right. So the first set of slides are on part of this set on Project Management Part 2, on risk management. So risk management is really about dealing with things going wrong. And that's an important part of planning. You don't just plan for everything going right. You also try to plan as far as you can for what happens if things go wrong. Okay, so projects do not always follow plan. And so good management means just try to deal as far as you can with things that go wrong. And actually, something that's often happens, things that a very common thing can go wrong, needs to be dealt with. But also, anyone who has a particularly serious effect, that also needs to be dealt with. We can't deal with every possible thing could possibly ever go wrong, just to try to deal with as many as we can. Okay. So that's risk management, dealing with things that go wrong. Okay, divided into project risks, and business risks, although some things are covered by all of those. So project risks, when something goes wrong with developing the project, perhaps with the classic example would be when one of the workers becomes ill and then can't carry on doing the work. How can you plan that? Product risk, what can be wrong with the actual programming itself? Something can be wrong with the actual programming itself that could cause problems. Business risks are really because software engineering, you're going to be part of a company, just working as part of a company. It may be that the company that you're part of could cause problems. Classic example of a company closing down. How can you deal with that, or asking to change it? So that's risk management. We really had lectures. I was going into more detail. Just go over it quickly. Various forms of risks, dealing with it, the risk management process. So identify what it is, analyze, plan, monitor. Okay. Okay, how do we do with it? Just be careful about new products. We do use new products. It's important to develop, but just be a little bit careful about using them. Ensure the environment is pleasant, so you keep your staff, because losing staff is a big problem. One of the key issues. Make sure that you've got enough staff to do it, and particularly as the key task that you're doing, make sure that you've got more than one member of staff that can do it, because if you lose a member of staff that does it, then you'll be stuck. Okay, so you might need to find another member of staff to do it, or perhaps train someone else to do some important task. dealing with the problems. Okay, so that was the risk management, and the next section, quality management. Okay, so what quality management is about. So what I'm doing here is just summarising what you've covered now in more detail in the rest of the lectures. Quality management is about dealing with the quality of a piece of software. Really, is it good enough to be released? And it says here, it's often a good idea to have a separate team which will check the quality. Okay, so someone that has not produced a program to come in and check the quality can be good to look at it independently, and that's often a good way to check the real quality. It's hard to know if you split the time work on it. That's the sort of idea. Well, Agile in some senses works differently, because where Agile works is to have frequently produced versions of the code and put out. Perhaps it's not quite so much about separate quality management, but how Agile works has a very big emphasis on testing. To always test, have lots of tests to test that the code works. And every time you add a new feature to it, do all tests again, automatic tests, to make sure it does not cause an error, so to make sure it's all correct. The Agile approach, very heavy emphasis on testing. Whereas the traditional waterfall approach says to do testing at the end, whereas Agile says do testing all the time as producing the programs. High quality software. Okay, right. Should meet specifications, but that's not as easy, because there'll be lots of specifications. To what extent can you meet all the specifications? And you've got to produce the code to be available in a particular time. So sometimes it may be that you can only get as far as producing some specifications when it's ready, when it's needed to be used. Okay, so in that case, you might use one of the most important specifications to work on first, to make sure they get done. Efficient and easy to use, that's very important, obviously. If code takes so long to produce the solution that the user requires, they stop working. And often it's very hard to tell that, particularly when you first learn to program, you just test code with perhaps very short amounts of data. You need to consider how to practice test it with large amounts of data, because in real world use, you're going to use large amounts. It's often it's the case that code which works perfectly fine with small amounts of data, so it becomes very, very slow with large amounts of data. That's something that you could look at more when looking at discussing algorithms and things, different algorithms for doing things. Okay, code invisible, and what we mean by this is that the user of a program isn't going to know the details of the code inside it. The user of a program just wants to run the program and see that it works correctly. The structure of the code inside it, okay, however, is important, and that's why we're going to go into detailed design principles, because well-structured code is very much easier to prove that it's correct and to modify it and so on. It's an invisible part of quality in the sense that the user of the program can't see the structure of the code inside it, but it's still important because it's really needed to be able to develop code further, but it's well structured, and to also test that it's correct. Okay, so fitness for purpose says, well, customers sometimes find it hard to say exactly everything that they need, so they can also, another good reason for producing code and letting customers use it is that helps them decide, is it really what they really want? Okay, so fitness for purpose is really about, is the code good enough to produce? Is it safe enough also? Because safety is an important thing. Remember, security is an issue. Can we be sure that it's not possible to use the code in a way which someone else could be able to use it to act as data which is meant to be secure and hidden, not used to it? Software, what else do we need to do? Yeah, plugin picture. You can read all of it. You can look at these slides, lectures on them to go from in detail, and you can look at them again in more detail. I would just look at them again in more detail to understand more carefully what they're also. So many different aspects of quality we give here. Okay, visible and invisible quality. Analysis of performance. Okay. Reliability. Okay, so this is about some of the issues. Is software reliable? Okay. Could it stop working? All those problems. Well, is it security? That's a very important issue, security. There's a paper here, and we've got it on the module website. You can get more detail on this paper to read it. It's quite useful. Put it up. Software standards. I will just go through this quickly. Okay, so the last section on the project management, we're just going to the history of software engineering. Okay, I'm really interested to say why we led to agile approach being the more common approach used. So Fred Brooks, this was perhaps the earliest book written on software engineering, published in 1975, or 20 years later, another one. So consideration of the human aspects of software development, with people producing software. That's the first book which so as software develops, it's become bigger and bigger and more complicated. Perhaps in those days it would have been shorter and simpler. As more and more use of software comes, it becomes bigger and bigger. So these become more an issue. Okay, so it's a very classic book from Fred Brooks. Okay, Mythical Man Month. Okay, Mythical Man Month. What this is saying is, how can you divide the task of producing a program between a team of people? Could divide exactly between a number of people? Well, no, it can't, because in many cases one part can only be done after another part is finished. Sort of a classic example. Okay, that's one thing that Fred Brooks says. If you bring in more workers to try and speed up production of software, something that can actually slow it down, because the time it takes to get the workers in, to get them being able to understand what the code is and how to look and start working on it, that takes more time. And that's the suggestion. Well, he said better to extend the deadline, but these days with Agile, it's better to produce perhaps a version which does not cover everything, but perhaps the most key aspects that are most needed are covered first, if you haven't got time to produce everything. Okay, another famous book by Ed Jordan, Decline and Fall of American Programmer. Well, his first book, this is this one, when he wrote it, he thought that software programming would be sent off to other countries, poorer countries, to do, because the programmers could be paid low amounts of money. That was really thought to happen a lot back in those days. That programming wouldn't be done much in wealthy countries, because you could do it, you just send it off programming to be done somewhere elsewhere in poor countries. Okay, that's what he suggested. Now, actually, that hasn't happened at all. Okay, and a few years later, he came across this. And there's a realization that programming, the actual writing of the code, is a really high skilled thing. It's not something you can just send off to someone else to do. And also, it's important that the programmers interact with customers to make sure it's done correctly. So actually, this is part of a way to move to Agile, and the importance of highly skilled programmers working on it. You can't just, the actual writing of the code itself is an important part of software engineering. And it's also important that it's very high quality code, because to give it to programmers who were not high quality programmers, the code would be very messy, very hard to understand, very hard to add things, and quite likely to contain errors. That's again the reason why it's important to have high quality programmers that really know how to write code, and not just how to write code that works, but how to write code well structured. And that's design principles. Then we're going to go into detail on aspects of structuring code. And that's the change. Okay. Problems about sources, problems with sending the code off to someone else to do. And the idea of programmers, a lot of projects fail, succeed. That's the issue here, how to deal with this. And again, we start talking about the Agile here. Started. Then. Okay, so design patterns. That's week 4. And just examples of aspects that could be problems with programming, or code smells. And that's a summary of that. Okay, so I'll go on just quickly through the sets of slides on project management. And so now I shall go through design principles. Okay, so there's one set of slides on design principles. It's a very long set. And so actually the idea of this set of slides on design principles is that if I was lecturing it in Beijing, as I've done in the past, something it can actually 2 or even 3 days to cover the whole of that one slide. So it's not, each slide is meant to last several days. Okay. So that's for design principles. So design principles is about sort of a general idea of it. So we're now looking at the actual code, how to write actual code. And with that, we've also got coding exercises. So I'm going to show you the coding exercises first, actually. Aliasing and inheritance. So we're giving these to you, the aliasing and inheritance exercise, because these are important aspects of programming. Basic aspects of programming, which in my experience, many people have not quite picked up. So these are not marked, but by doing them, you can learn. So this is the exercise Java aliasing. It's just the example of code it's using, and the code is there, and the exercises. Okay, so all it's saying is what would this actually print? And the important thing to understand is dealing with, because it's a simple one first, dealing with variables, and when variables are set to other variables, what does that actually mean? Okay, so what this means is Act 2 refers to the same object as Act 1 refers to, for example. Okay, so that's the aliasing exercise. There will be solutions made available for them later on, but I would suggest do them first. So we're not yet. Okay, an inheritance exercise, I'll show that. Okay, use of inheritance. So again, do you know how to write subclasses? Again, use a class bank account, and right there are subclasses of it and see how it works. And there's also test code we've got here, which makes use of the, so you can use this test code to test the code you've written. So I would just strongly suggest that in order to learn properly, you do these coding exercises. It really does help a lot in learning to do them. Just check what's happening here. Okay, so please do feel free to ask questions. You can email me or send them on the no, let's just go back to show you that in case. Yeah. Okay. This is broad. Okay. I would really like you to make use of the message board to ask any questions you have about any aspects that we've taught. It's important because if you use the message board, then everyone can share the answers to it. So you can do it that way. And but if you want to email me individually to ask questions, I will take that as well, and I will reply to your email. You can do that, but I would prefer that you use the message board so that everyone can share in the answers that we're given. Now, the other thing I've done on the module announcements, okay, I'm sending some extra material on the modular announcements. This is actually mainly to deal with some questions that were asked in the office hours. And they're really mostly about these aspects of coding, so abstraction. So I'll just add a little bit of extra material. So please do feel free to look at these. And if you ask more questions, that I will produce some more some more on the module announcement, some of these things which I think need to be covered in more detail, okay, or where people have not perhaps understood quite what they are. So there's a few things I've done so far here. I've added those. Okay. Oh, and let's go back to week 3. Just to say, okay, So this is a bit you can't see yourself. There's solutions. We will be made. This is as me as a user. I can see it as a module organizer. I can see it. You can't, but will be made available later. Samples of code. I also recommend to do make sure when you do some extra reading of the software engineering books that are provided. I'm also giving you some additional reading here. Okay, this is the paper on project management, software resiliency, which is mentioned. So you can do that. Now, what I've also put up here, let me just show it to you. Object analysis and design and sorting. Now, let's know what these are. These are actually slides that I used for my teaching at Queen Mary in London. Okay, so these are slides actually from my module. Well, I teach part of the object-oriented programming module at Queen Mary, and I uploaded a couple of sets of slides I used for that. Object-oriented analysis and design. Okay, so I'm not going to go through these lecturing them, but I thought since they cover a lot of things which are quite similar to what's covered in this aspect as part of software engineering, I thought it's good to make them available. Okay, so this is my lecture on object analysis design for this module, object-oriented programming at Queen Mary. And in particular, this covers design principles as well. So if you want to do more design principles, you can look at these. I think I actually give more detail in the software engineering module here, but if you want to just look at what I've written here, it's also there's more perhaps on code here. Okay, so that's that one. And the other one is on sorting. I'll just explain why I'm doing this. Sorting is often just a good example of general principles of how to write code. So, for example, sorting is there's generalizing code. So you can use one piece of code to do sorting. I'll put that in the message. Sorting, one piece of code to do sorting, rather than have lots of separate pieces of code. And also sorting is a good idea to illustrate the principle that you might start off by using an inefficient algorithm. If you realize there's a more efficient algorithm to do it, if you wrote lots of repeated code, you have to change all the code. If you have one generalized code, then you just need to change that one piece. So sorting is just there because it's quite a good way to illustrate some basic aspects of programming. In reality, you never need to write your own code to use sorting because there's built-in sorting methods in most programming languages like Java. But it's a good way of just giving an illustration of aspects of programming. So that's why it says sorting. So again, there's just some slides on sorting here. Okay. Right. So as I said, the first half of lecturing in week 3 was on project management. And then the second half was on design principles. And I think design principles on the actual code can be one of the most challenging parts of the module to understand. It's actual detail of coding. But it's important to be able to understand these aspects of coding. And that's why it's covered in detail. But the general design principles is how to structure code well in order to be able to understand it well, to be sure it works quickly, and in order to be able to ensure that new features can be easily added to it. So again, let's go quickly through the design principles slides, which of course you would have gone through in more detail in the lectures. Again, so there's recordings 21 to 26. Well, let's just go back to where we are. Yeah, cue lecture recordings here. Okay, design principles. There were actually 6 design principles which were originally produced by me a few months ago, before we realized we wouldn't be able to lecture this year in Beijing because of an unfortunate situation. So they weren't produced for that reason, but because they've been produced, we are using them now for this module. They're a little bit short. If I were lecturing in Beijing, I would probably or lecture a little bit longer in more detail, but they perhaps summarise the issues. So I still would say, do look at these lectures, but also read carefully through the slides, which are quite detailed as well, to understand more. Okay, so that's where the lecture recordings are. So I'm now going to just quickly go through the design principles slides, just to summarise what they're all about. Okay. So, could we divide into 3 sections, which perhaps would be lectured in 3 separate days, if I were lecturing in Beijing. So the first section is just on general aspects of programming. So again, just to summarise what software engineering is about, all aspects, requirements and design, implementation, and testing as one, but more of a coding aspect. But also, it's about the general human management of it as well, use of tools and business issues, modification, ethical issues, or legal issues as well, good issues as well. It's important as well. Okay, so many of these things we can just cover briefly in this module, but they are important. Trade-offs. Okay, it's an important thing to understand as well. So software must, of course, meet requirements and be convenient and safe, but also it has to be produced within a time limit. So there could be a balance between these 2 things. If we spent so much time trying to produce software that's absolutely completely perfect, then it might just take too long to produce it. So getting the balance between these things right is an important aspect. Software lifespan. This is an important thing to understand about the way that real life software will last for a long time. So when you learn to program, you write code for exercises and for exams. It's finished, it's finished, and it's the end of it. Whereas real software is going to be used and reused for many years and modified to add features to it. So that's why it's very important for it to be so well structured. And that's the other thing, that's the size of software for real software is going to be huge, much huger than the sort of software you write when you first learn to program. Just an email from me. So, okay, so design principles are really about attention to high quality design implementation, essential to manage complexity of real world software systems. So right program in a casual way, when first learning to program, you must be much more careful as a professional programmer, well structured code. So not enough it works correctly, written away makes it easy to develop further. That's the key aspect here. Okay, dangers of poor quality code. It can be sure it works correctly. How can we be sure we change one aspect, it might damage other aspects. So poor quality code can cause more and more problems as it goes on. So poor design early on, experiences later. What that means is that if you started off producing it poor, it could cause many more problems later on as the code is changed or reused, or it's caused errors that are hard to find out and all that. That's the issue there. Security problems. So security is, again, we can just briefly mention it in the module this time. It is an important issue. How can you be sure that you haven't written code which would enable someone else using the code to access data which are not meant to be able to get into and access and change? As we know, in security, you can actually, broken security can actually steal money in that way. It can be done. Okay, so decomposition, and that's the important issue here. Divide code into separate parts. We call it modules here. You can think of it as classes. So that's the basic idea of object programming, is that code is divided into classes, but also divided into packages which contain classes. And a class may itself make use of lots of other classes that it's developed just for its use. So that's really the structuring code in that way. It's a big issue. The important thing is to be able to break code into well-defined separate parts. That's really the key issue with program is well designed. And that's why object-oriented programming is so important, because object-oriented programming is the first way to divide code into separate parts. And you think of code as objects interacting by calling methods on each other, rather than the details of what's inside each of the objects. It's important to do it that way, because if you just think of it just in terms purely of variables, storing integers and strings rather than objects, a code will become just so more complex to understand and to develop and use. It's important to think of it primarily in terms of an object with methods called it. You don't need to know what's inside the object, as long as it works correctly. You know it will always work correctly. That's how we divide code into separate parts. So we can use one part without having to know it, or you can write one part without having to know, reduce all the code and use it elsewhere. So locality and modifiability, that's what it means. Implement a module. We have to examine the details of modules, and also re-implement it without requiring change to any module. So if you want to change how the module, a class works, perhaps make it more efficient or better quality code, you should to do that and be sure that doing that is not going to cause any problems to any other code elsewhere. And that's why it should only work according to the defined methods called on it, not in any other way. And that's why we go on to some issues. How can we make sure that's the case? Okay, so software systems and modules. Define whether services refer to other modules. That's the key thing. A specification of how a module, we can think of it as a class, works in terms of the methods called on it. And cannot interact in any other way. That's really important. And how can we make sure we write code that is the case? So we could think of a module here as being a class. Okay, another key aspect, separation. What an entity does from how it does it. Very important aspect of programming this. Make sure that you should separately think of code. What's the code inside that makes it work? That's how it does it. What does it do in terms of how it interacts with other code? Keep a clear separateness between these two aspects of code. And that's what's separation. Splitting methods and classes. Okay, this is one aspect. Feel free when writing code, if a method or a class becomes long complex, could you do a separate method? Could you split into separate classes? It's really best to do that because it helps structure the code well to do that. Also, make sure that you give your classes methods names which help say what they do. Okay, give them meaningful names. That's another important aspect. So if code is long complex, could you break it into separate parts? So variables related, could you put them into a small class to hold them? So you treat it as a class, an object with them, rather than separate methods to make the code more complex. Okay, so help methods and classes. This is when you are producing code and you decide to break it up into smaller classes and methods. You still must only produce directly for public access the methods that are required, asked for, and the classes that have been asked for. So if you split something up into separate classes and methods to help, they would be delivered as private because that's used only for internal use by the code which uses them. So that's just public and private. So we call that helper method, helper classes which are given not as part of a definition, overall definition, which should do, but because it's become a better structure, it's divided into separate classes and methods. And you can even declare a class inside a nested class in a language like Java, and then other programming languages as well. Reuse. That's an important aspect. Instead of writing new code for a module, make use of existing code, and that's really good. That's another key aspect of good quality programming. Write it in a way that they wish to reuse existing code rather than to keep writing new code where possible. Just finish quickly because we need to finish fairly soon now. Abstraction generalization. So I've sent some messages about this, what these mean, in terms of the actual coding aspects of it. UML diagrams. Okay, we usually see UML diagrams. There were diagrams that were expressing the general structure of code using UML diagrams. We'll cover in more detail here. We'll just go quickly through this. So class defines an object. The various things a method call can do, lots of different things. It's best to try and limit the method so it only does one thing. Otherwise it becomes more complex and difficult. Static. There wasn't reference. This is a key thing, and that's the there wasn't referencing was what I gave an exercise on. And I've done that because many people don't properly understand exactly how concept of a variable referring to an object. So what it means is a variable in a programming language like Java and other programming languages as well stores the. It doesn't store the data of the object. It stores the position of the object of data elsewhere in the computer memory. So it stores a position. So what that means is if you assign one variable to another, it changes the position. So it means that the two variables refer to the same object. That's what we call aliasing. Understanding that, the consequence of that, is a really important part of programming. And I'm mentioning it in detail here, particularly because it can be a security issue and a problem issue. If you're not careful, it could be that other code can access data which it couldn't do because of aliasing, or it could cause some unusual problems with code because you didn't realize that two different variables refer to the same object. So it's an important thing to understand. Okay, so points diagrams. Just to listen quickly, what this means is that these are variables, and arrow says it's a variable referring to an object. So can we call var2 equals var1, var2 such referring to what it used to refer to, and such referring to what var1 refers to. That's the basic of aliasing. And this shows, okay, so here we've got val is a variable inside an object, okay? So val sets it to what var4 refers to. It does that. But now we've got var4, and they're referring to the same. Now, if that was an object with something else inside it, that could cause problems. Okay, something it doesn't. It depends on the nature of the object whether that would cause a problem or not. And if nothing refers to an object, it disappears. And it's really it's memory. It can then be reused. And that's garbage collection. So just take care with aliasing. That's what we're saying at this point. So I'm covering it in some detail here. Also, good to make immutable. If there's no method which can change an object, sometimes that can be done. If you can do it, it's useful because then it's safe for variables to age the object, because one variable cannot change it. Can't call a method from one which changes, because otherwise the other would see a change as well. So exposure representation, this is just a detail of some code which shows how, if you're not careful, so another variable would access what's meant to be just inside an object to be part of this representation. So I won't. You can look at it in more detail to understand it. Computers not intelligent. What do we mean by this? Computers only do what they're programmed to do. Okay, so we know exactly what they're going to do. They only do exactly what they're supposed to do, nothing else. Whereas a human, you can ask a human to do something, and you can't be quite sure what they're going to do and how they're going to do it. Whereas computers can only do exactly what they're programmed to do. So that's why computers are not intelligent. Programming is sequential. As a standard program you write does one thing after another, but of course, realistic large-scale programming does use threads, so several things happening at the same time. We have not got time to cover that, but it's a very important issue we could take further. Okay, design principles, most basic. So this is the most basic aspect of programming. Classes written, so objects define things, and the image of, well, that's the image of classes define actual objects. But as we go further, we have classes which are there to define objects which perform various aspects rather than represent real objects in the world of the program we're writing. Code written so objects can only interact with defined method. That's perhaps the most important aspect of programming. Make sure that the code only works by defined method calls, can't interact in some other way. Because if it did, it could cause problems. Much harder to make sure the code is correct, much harder to make changes to it, introduce new features and so on, if code could interact in an unexpected way. Okay, client contractors, just another way of thinking of breaking up code into clients and contractors. I won't go into detail on that. Okay, so this is the final section on design principles. Design principles 1 is perhaps the most important aspect of design principles, the single responsive principle and the open close principle. And then design principles 2, the next section, goes into some further detail on further aspects of design principles. So the most important one is the single responsibility principle, which is about making sure each piece of code just performs one particular task, one particular reason for doing it. Every operating system should have a single responsibility. All of service should be focused on carrying out a single responsibility. Or class shall have only one reason to change. Okay. Cohesion, coupling. Okay. Well, we'll just go through it quickly. I won't go into detail on this. We'll give an example here, this employee. So in the initial case, the class employee would have loads of different coding to do different things. And what this example is saying is it would be better to split that up into separate classes to do these separate tasks. And it's just 2 ways of doing it. So class employee does calculates its pay, pushes a string to give its hours, information saved to the database. If that was all in one class, that would be a very complex class. Could it be broken up into separate classes? That would not meet the single responsibility principle. Okay, that's what it says here. Low cohesion. Okay, this is delegation. So what delegation means is you have a separate object to perform a task. So here we're delegating the task to perform into a separate object, a payroll calculator, database store, an hours formatter, and we call a method on them to do it rather than have the code for it inside class employee. That's the point here. Okay, and here's the UML structure for it. It's still fairly complex. And that's why we've moved it to another way of doing it. So each employee has a payroll calculator, which refers to employee and refers to the payroll, and that does the calculation. And it's a simpler structure. Dependency. Okay. So this is just more details of code. I need to get through this very quickly. So the second thing is the open close principle. Okay. So it's good, important for code open for extension, closed for modification. In other words, you can change the way code works without changing the actual code itself, and that seems to be contradictory. So there's ways of doing it. Well, here's an example of abstraction. I guess this is sorting. Write it in a more generalized way. I've already mentioned that. Sorting is an example. And how to write abstraction. Again, I've given the messages about this. So writing code we want to use it for different purposes. So to write code in a way we can make it useful as written. That's the important thing. That's really what the open close principle means. How can we do that? And another thing is don't repeat yourself. Okay, so if you find yourself writing code which is very similar to some previous code, think about, can you generalize that code so you could reuse it rather than have to use separate code? That's what generalization means. Writing code in a more generalized way so it can be reused. Even if you've written it before, less generalized, can you change it, make it generalized to reuse? So the classic example is better to have one generalized sort method rather than lots of different sort methods to sort classes of different collections of different objects. Just one generalized sort method. And that's what generalization is. Okay. So inheritance is one way of meeting open close principle, because if you want to have vary the way that a class works, an object of a type class works, you can do it by inheritance. You write a subclass of it, and the subclass inherits the code. It doesn't have to have extra code written in it. It only has to have the code in it which changes it. So inheritance was one way of meeting the open close principle. And also a method which takes an argument of a superclass can also take an argument, an object whose actual class is a subclass, so it can use the same code. Parameterization is where code is generalized by passing in an object which performs part of a task. And the classic example is, again, sorting is good as well. This is most, but sorting would also work. So this is find the biggest. So here we find the biggest according to integer string, going to the biggest, longest string of longest length. Here's more generalized code. We're passing a comparator to compare objects. So for comparator compared to strings according to their length, it would do that. Compared to strings according to some other reason, it would do that. So that's more generalized code. So parameterization is a way of meeting our principle by passing in a parameter which does part of a task, and different objects which meet fit the parameter type will do different things. Okay, let's quickly on to the last set of design principles: dependency inversion principle, interface segregation principle, and the list cost substitution principle. I will just go through it quickly. Again, do look at the slides in more detail for what they cover. And I'll give this example of generalization. Okay, a duck and a duck call using interface types. So essentially, what we're saying here is it's best to use interface types because it's a way of generalizing code, and it makes code simpler. Okay, so we tried to a complex. It's an example of bad code trying to write complex classes because it represents more than one thing. It doesn't really work well. Let's quickly go. So this is the inversion principle. High-level modules should not depend on low-level modules. So write code and generalize it. It doesn't need to have any requirement of the details of the other code that it's using. Okay, so for example, it's best not to check lots of instances of checking that. And perhaps one way of doing it is just to make a lot of use of interface types. So always refer to objects through interface types rather than through class types, which might give more detail. An interface segregation principle, which takes it a little further and says that an interface type should just be small number of methods, rather than have an interface with lots of methods. Because if you don't need all those methods for every object class implements the interface, then it's better to have separate interfaces. And then again, a way of writing code well structured, where the interaction between different pieces of code is limited, and that makes the code better, less likely to have problems, easier to modify if you do that. So that's the interface segregation principle. I'll give you a little example here. Generalization again, and well, I'm just going to do a quick one. We've almost finished now. More examples of code given. Lots of examples. So I'm going to go quickly to the last one. Yes, there's plenty of examples. I'm not going. I haven't got time to go through into what we do. But look at the code. Gives more examples of coding. The last thing is list cost substitution principle. That is about being careful of inheritance. So we said inheritance is a good way to meet the open close principle, but be careful. Well, this cost substitution says don't use inheritance if it produces a class which works in an unexpected way, does something different from how it's meant to do, from how the superclass was. You can override a method in any, lots of the signature is the same, but if it does something different, unexpected, it could cause problems. So list cost substitution is essentially be cautious about using inheritance. It's really essentially what it means. Okay. So we're writing equals, for example. Okay, so the last bit, just some general aspects of how to study this material. So do read this and understand how to study the material. Okay. Right. Okay, so we'll finish at that point. Okay, so thanks everyone for coming. I hope this is okay. I hope it's gone well. Okay, but please do feel free to send me messages to do it.